y prime is 3x squared minus 6x minus 24. Set it equal to 0. I saw most people factored out the 3 and then factored it further. X minus 4, x plus 2, x equals 4, x equals negative 2. Good thing about factoring this 3 out, I saw a number of you thinking, does that mean that here I have another place where I could have a stationary point? But this value out in front, being a 3, is never equal to 0. There's no x out there, so we can't actually add another point to it. Some of the other things that can help you think about this is we have an x cubed graph here, so you know the shape of an x cubed graph. The most amount of maximums and minimums is one of each that you could have. So now when we go to our line here and put negative 2 and 4 on here, when I plug in a value less than negative 2, I get a positive number going up. Here we get a negative number going down, positive again going up. So we know that negative 2 comma something is a local max, and 4 comma something is a local min. And what did you get? Negative 2 comma 23 and 4 comma negative 85. Oh, nice big numbers. So second derivative will be 6x minus 6, making that equal to 0. Moving the 6 over and dividing by 6 gives x equals 1. If we see our values before this, plug in a number less than 1, you will get a negative, meaning this part is concave down, and bigger than 1, you'll get a positive, meaning this part is concave up. And so we have an inflection point at 1 comma, someone have that value? Negative 31. Okay? Now, we've got our max, we've got our min, we've got our inflection point. Just looking quickly at this function, whether or not I could factor it nicely, doesn't look like it would be easy to factor or something obvious. My y-intercept, though, that I could find quite easily. So we may as well add that point to our graph as well. When I plug in 0 for x, all those things will go away and you'll just be left with minus 5. So we've got our y-intercept as well. So now when we go to graph this, looking at the values I'm going to have to do, 4, negative 85 seems to be the largest of the numbers. So I'll put that one down there. Negative 2 comma 23. So if that is 85, that distance, I would estimate 23 to be about there, and 1, negative 31, about there. We know that our y-intercept is at 0, negative 5. So we would get that value there. So, and those ones we could only get from our calculators. So if I added, you said there's one at about 6.9, one at about 0, and one at about negative 3.5. So those values, though, we could only get them with our graphing calculator. So I put them on in red. Everything else is stuff that you could find without. Now, based on concave up and concave down, from this point, it's all concave down. I'm going to go through there like that, and then concave up after this point. And there we've got our sketch of our graph.